Hello everyone, once again welcome to PM Networking. Guys, in last video of VPN series we had discussed what is GRE, how generic routing encapsulation works, and today in this video we are going to discuss what is the disadvantage of GRE, drawback of GRE, generic routing encapsulation. So here I am going to configure this network. I will show you what is the problem with GRE, okay, point to point VPN. So you can see, first of all, I will configure IP address on this device. So here between R1 and ISP, this is my public network 100.1.1.0/24. This is my public network. I will configure between R1 and ISP. On ISP, I will create one loopback 8.8.8, right? So this is my LAN user. This is my LAN network. So I will configure PAT on R1 as well, so that this LAN user can communicate with internet. Right, first of all, then I will show you how this LAN user will communicate with the LAN user which is located in different network, which is located in different location, right? Suppose this is my branch router, right? This is my headquarter and this is my branch office, right? This is my branch network, this is my branch network, and this is my headquarter. Okay, so we will create tunnel, point to point tunnel between headquarter and branch office, right? So this is my hub router, this is my spoke router, right? This is hub router and these two are spoke router. So topology is like hub to spoke. So reason to make this video is to make you understand the drawback of GRE. Then in next video I will show you solution of this problem. Solution is DMVPN, right? So in next video we will discuss DMVPN, NHRP protocol. Okay, so this is also my spoke router. Okay, so first of all I am going to configure IP address. If you want to escape, you can escape it. IP configuration, right? Here between R3 and ISP I am going to run this public network 101.1.1.0, right? Between R2 and ISP I am going to configure this network, this public network, right? And this is my LAN 1 which is connected to my headquarter router. This is 10.1.1.0. 20.1.1.0/24 is connected to my spoke router, right, to my branch 1. Suppose this is my branch 1 and this is my branch 2. So this is LAN 30.1.1.0 which is connected to branch 3. Okay, so let me start. Let me turn on the device first. I am going to show you configuration, GRE configuration step by step. Then only you will came to know what is the disadvantage of GRE. Okay, so first of all let me configure ISP router. I will configure IP address on ISP router only. After that I will not have access of ISP router. Okay, so go to configure terminal, interface fast Ethernet 0/0. So here you can see network is 100.1.1.0. So here I am configure IP. I will configure IP 100.1.1.2, and on R1 fast Ethernet 0/0 I will configure 100.1.1.1. Okay, so IP address is 100.1.1.2, subnet mask 255.255.255.0. exit interface fast Ethernet 0/1, no shutdown. IP address, here I will configure 101.1.2 255.255.255.0. exit interface fast Ethernet 1/0, no shutdown. IP address is 102.1.1.2 255.255.255.0, and let me create one loopback, interface loopback 1, and IP address is 8.8.8.8. subnet mask is 255.255.255.255. Fine, now let me close it. Now I will not configure anything on ISP router. Fine, let me configure IP on R1. So this is R1, configure terminal. Interface fast Ethernet 0/0, no shutdown. IP address is 100.1.1.1, subnet mask 255.255.255.0, exit. And on LAN interface I will configure 10.1, 10.1.1.1. .255.255.255.0, right? So IP configuration is done. Let me configure one default route towards ISP as well. So IP route 0.0.0, 0.0.0, and exit interface is suppose fast Ethernet 0/0, right? On edge router you have to configure default route. We have discussed these things in theory. Okay, now let me configure IP on R2. Configure terminal. Interface fast Ethernet 0/0, no shutdown. IP address is 102.1.1.1, 255.255.255.0, exit. Interface fast Ethernet 0/1, no shutdown, and IP address is 30.1.1.1, 255.255.255.0, exit. IP route 0.0.0, 0.0.0, and fast Ethernet 0/0. Okay, now let me configure IP on R3. Interface fast Ethernet 0/0, no shutdown. IP address is 101.1.1, 255.255.255.0, exit. Interface fast Ethernet 0/1. This is my LAN interface, so IP address will be 20.1.1. Okay, so here on R3 I am running 20. Okay, no problem. 20.1.1.1, 255.255.255.0, right? After that, default route. So IP route 0.0.0 and 0.0.0, exit. Interface is fast Ethernet 0/0. Now you can see ping. First of all, let me ping my public IP address. My destination public, my neighbor public IP address is 101.1.1.2. From R3, see, I am able to ping. Let me ping 8.8.8, 8.8.8.8. Yes, I am able to ping. Yes, it will ping. Okay, but I am not able to, my LAN user is not able to communicate with internet, because you can see ping 8.8.8 and source is 20.1.1.1. because why my LAN user is not able to ping 20.1.1.1. invalid source. Let me check IP. So IP interface brief, so 20.1.1.1 interface is down. Let me run no shutdown command on interface F0/1, no shutdown, right? Now ping 8.8.8.8 from 20.1.1.1. So to make communication possible between private network to internet, we have to configure PAT on this router. In the same way you can check on R1 as well, right? Ping 8.8.8.8, source is 10.1.1.1. Why I am not able to ping? See, first of all, where my traffic is dropping. So IP interface brief. Okay, so this interface is down. Interface fast Ethernet 0/1, no shutdown. And let me check same thing on R3 as well. Okay, on R2 as well. So go to R2, ping 8.8.8.8 and source is 30.1.1.1. I am not able to ping. Right now, see where my traffic is dropping actually. Epic Just wait guys. See, when you will ping 8.8.8.8 and source is 10.1.1.1, right? So destination will be 8.8.8 and source will be 10.1.1.1.1. So R1 will check their routing table to forward traffic to 8.8.8.8. Let me show you the routing table of R1. See, so IP route. There is no any entry for 8.8.8, but there is one default route towards ISP. So R1 will forward this packet to ISP. And guys, private network is not allowed, private IP address is not allowed on this interface because this is ISP interface. And how ISP router will generate reply, because in the routing table of ISP router there will be no information of 10 network, 10.1.1.0 network, right? So you have to configure PAT over here so that this router will translate this private network into public network, right? So let me configure PAT first on R1. Go to configure terminal, access list 10. I had discussed that how PAT work, how NAT work, what is network address translation, how to configure. So I am not going to discuss this thing here. Okay. After that, permit, and network is 10.1.1.0. Wildcard mask is 0.0.255. After that, IP NAT inside source list 10 interface fast Ethernet 0/0. That means we are telling to this router match source from list 10 and translate that network into the IP address which is running on fast Ethernet 0/0. Okay. After that, go to interface fast Ethernet 0/0, IP NAT outside, exit interface fast Ethernet 0/1, IP NAT inside. Okay. Now you can see ping 8.8.8.8 and source is 10.1.1.1. Yes. Now my LAN user are able to communicate with internet. Now my LAN user can access Facebook server, Google server, right? So in the same way, let me configure PAT on R2 also. Go to configure terminal so that my LAN user can communicate with internet. Okay. So IP NAT inside source. Okay. First of all, let me create one access list. Access list 10, permit which network 30.1.1.0. Wildcard mask is 0.0.255. IP NAT inside, and source will be match from list 10 and translate it into the IP address which is running on interface fast Ethernet 0/0. After that, interface fast Ethernet 0/0, IP NAT outside, exit interface fast Ethernet 0/1, IP NAT inside. See, is my LAN user able to communicate with internet? And source is 30.1.1.1. Yes. Now my LAN user are able to communicate with internet. But in the same way, let me configure PAT on R3 as well. Access list 10, permit 20.1.1.0, 0.0.255, IP NAT inside source, match from list 10 and translate it into the IP address which is running on interface fast Ethernet 0/0. After that, interface fast Ethernet 0/0, IP NAT outside, exit interface F0/1, IP NAT inside, right? Ping 8.8.8.8 and source is 20.1.1.1. Now my LAN user are able to communicate with internet. Now all LAN user are able to access internet, but my LAN user is sub 10.1 is not able to communicate with 20.1. Ping 20.1.1.1. You can see. So these LAN users are not able to communicate with each other, right? So we need to create tunnel. So here I will create one tunnel. Okay, so first of all I am going to show you how to make communication possible between these two LAN. Okay, so I am going to create tunnel 1 over here on this router and tunnel 1 on this router, right? Tunnel IP address will be 10.1, right? And tunnel source will be this one and tunnel destination will be this one, right? So tunnel IP address on R2 on branch router will be 10.2, tunnel source will be the IP address of this interface and tunnel destination will be IP address of this interface, right? This interface. So you can see here I will create this tunnel. Tunnel 1 IP address is 10.1, tunnel source is 100, this one is tunnel source and tunnel destination is this one, right? Whatever IP address you are running on this interface, 10.101.1.1.1. Okay, first of all, and let me create tunnel 1 on R1 first. Interface tunnel 1, IP address is 192.168.10.1 255.255.255.0. After that tunnel source is 100.1.1.1 and tunnel destination is 101.1.1.1. Fine. Okay, now go to R3. Let me do same thing. Interface tunnel 1, IP address is 192.168.10.2 255.255.255.0 and tunnel source is 101.1.1.1 and tunnel destination is 100.1.1.1. Fine. Let me show you, am I able to ping my destination tunnel 192.168.10.1. See, I am able to ping my destination tunnel, but still I am not able to ping 10.1.1.1, right? Because when you are pinging 10.1.1.1, R3 will check their routing table. In the routing table of R3 there will be no any entry for 10.1.1.0 network, so it will use default route and it will forward to ISP router, right? Okay, see what will be the source. Source will be IP address of exit interface, that means 101.1 and destination is 10.1. Fine. So how ISP router will forward this traffic to R1? Because you can see here destination network is private network. Destination network is private network. So GRE will not add any header. So what you need to do, either you can configure a static routing for this network on R3, or you can configure any dynamic routing like EIGRP, OSPF. Fine. So actually you have to inject this network in the routing table of this router with exit interface, tunnel interface, right? Exit interface will be tunnel interface. Then only this router will add GRE header. Am I right? So you have to inject this network in the routing table of R3 with tunnel interface, or you have to inject this network 20.1.1.0/24 in the routing table of R1 with tunnel with exit interface tunnel 1, right? So either you can configure any dynamic routing protocol or static routing. So here I am going to configure a static routing first. So go to R1, exit, IP, root, which network? 20.1.1.0, subnet mask is 255.255.255.0, and exit interface is tunnel 1. Now you can see the routing table of R1. So IP root, there is one default route, right, and there is one 20 network, and exit interface for this network is tunnel 1. So whenever router will forward traffic on tunnel interface, it will add GRE header. Okay, in the same way, let me configure a static route on R3. So this is my R3, IP root 10.1.1.0, 255.255.255.0, and exit interface is tunnel 1. Guys, now you can see ping 20.1.1.1 and source is 10.1.1.1. Yes. Now the LAN user of this network is able to communicate with the LAN user of this network, right? But there is no any entry of private network in the routing table of ISP router. So communication is happening because of GRE header, right? GRE is adding 24 bytes extra information with your actual ICMP packet. Fine. Now you can see, go to R3 and you can ping 10.1, ping 10.1.1.1, and source is 20.1.1.1. Yes, I am able to ping. Now I want to make communication possible between these LAN user to this LAN user. Now still this LAN user is not able to communicate with this LAN user. This LAN user can communicate with this LAN user only, right? So we need to create one more tunnel over here, right, between R1 and R2. So I have created one tunnel between R1 and R3 to make communication possible between these two sites, right? And now I am going to create one more tunnel to make communication possible between these two LAN. Fine, just wait. So first of all, I am going to create one more tunnel on R1 on my hub router. Go to configure terminal, interface, and now tunnel 2. And IP address of tunnel 2 is 192.168.20.1. So I am running 20 network, 192.168.20.0 network between R1 and R2. Okay. So IP address is 192.168.20.1, subnet mask 255.255.255.0. After that, tunnel source will be same 100.1.1.1 tunnel source. After that, tunnel destination, and this time tunnel destination will be 102.1.1.1, right? Okay. Now let me configure same thing on router 2. So go to router 2 and interface tunnel 1. IP address is 192.168.20.2 255.255.255.0. After that, tunnel source is 102.1.1.1. tunnel destination is 100.1.1.1. This is my R1. Okay, now you can see am I able to ping this tunnel? Ping 192.168.20.2. Yes, I am able to ping both tunnel 10.1, 10.2 and 20.2, 10.2 and 20.2, right? But I am not able to ping 30.1.1.1 from 10.1.1.1. You can see. Yes, my LAN user is able to communicate with internet, but my LAN user is not able to communicate with the LAN user which is connected to router 2, right? So what we need to do, why I am not able to, why my LAN user is not able to communicate with 30 network? So IP route, because you can see for 30 network there is no any entry, but there is one default route, right? So if this router will forward this traffic to ISP directly, it will not add GRE header, right? So I have to configure a static routing again. So same thing, let me do IP route. Let me configure a static route for 30 network on R1, 30.1.1.0. Subnet mask is 255.255.255.0 and exit interface is, now exit interface is tunnel 2, not tunnel 1, right? Because this network is connected to R2 and we have created tunnel 2 with R2, right? Now go to R2 and let me configure a static route for 10 network, because by default you can see the routing table of R2, there is no any entry for 10 network. There is no any entry for 10 network, right? So configure terminal IP route 10.1.1.0, subnet mask is 255.255.255.0 and exit interface is tunnel 1. Now you can see, so IP route, there is 10 network, yes, and exit interface is tunnel 1. So it will add extra 24 bytes header information, right? Whenever router will forward traffic on tunnel interface, we had discussed this thing in theory. Now you can see ping 10.1.1.1 and source is 30.1.1.1. I am able to ping, yes. Now all my LAN user are able to communicate with the LAN user which is connected to my headquarter, to the hub router, right? Now am I able to ping 20.1 from here? 20.1.1.1. See, now this LAN user can communicate with this LAN user, this LAN user can communicate with this LAN user, but can this LAN user communicate with this LAN user? No. Why? Because when you will ping 20.1.1.1, what this router will do, this router will check their routing table, because source will be the IP address of exit interface, that is 102.1.1.1, and destination will be 20.1.1.1. see, ping 20.1.1.1 and source is 30.1.1.1. so when I will hit enter, ICMP request will be generated at R2. Source will be what? Source will be 30.1 and destination will be what? 20.1. It will check their routing table. R2 will check their routing table. See, I am not able to ping. So in the routing table of R2 there is one default route. There is no any specific entry for 20 network. So again you have to create, we have to configure one static route for 20 network, right? So IP route, there is no 20 network. So go to configure terminal, let me configure one static route. IP route, which network? 20.1.1.0, subnet mask is 255.255.255.0 and exit interface is tunnel 1, right? In the same way, let me configure a static route on R3 for 30 network. Configure terminal, IP route 30.1.1.0, subnet mask is 255.255.255.0, and exit interface is tunnel 1. Fine. Now guys, am I able to ping 20.1, and source is not 20, 30. I am pinging from R3, 30.1.1.1, and source is 20.1.1.1. You can see. Now I am able to ping 20.1 from 30.1 from 20.1. Now all LAN users are communicating with each other. Now all LAN users are communicating with each other, right? This LAN user can communicate with this LAN user, this LAN user can communicate with this LAN user and this LAN user, right? So all LAN user can communicate with each LAN user, right? So this is how to make communication possible between two or different site, between two or more private network over public network, because this is my public network and this is my private network, this is my private network, this is my private network. So this is how you will make communication possible between private to private over public network. But there is some problem. See, problem number one is these LAN user are communicating with this LAN user via hub router, via headquarter. But my requirement is this LAN user should communicate directly. Problem number one. And here is only two sites, right? There are only two branch. So we need to create two tunnel on hub router. Suppose guys, if there are 100 branch, then we need to create 100 tunnel on headquarter router, right? So this is not scalable. So this is problem with GRE tunnel. Okay, first problem is these two LAN users are communicating via hub router, via main branch router. And second problem is you have to create more number of tunnel on hub router, right? Number of tunnel on hub router will be equal to the number of branch. So suppose there are 100 branch, then you have to create 100 tunnel, right? And these LAN users are communicating through main branch. So CPU, let's think about the CPU utilization of this router, right? So this is not a scalable method to make communication possible between different private network over public network. Okay, so solution is DMVPN. This is point-to-point VPN. This is problem. There is no problem if we have only two side or three side, right? We can create two tunnel on hub router. But problem is if we have more number of branch, then you can't use GRE tunnel, right? Then you will never configure point-to-point VPN. Then you will configure DMVPN. So in next video we will discuss DMVPN, how DMVPN work, and how to make communication possible between private network over public network through DMVPN. But let me discuss something more in this video. This problem is, okay, I don't want to configure a static routing, right? I want to configure EIGRP routing protocol. EIGRP routing protocol. So you can do the configure any dynamic routing protocol as well. First of all, let me remove static routing from all router. So this is my R1, no IP root, which network? 20.1.1.0, subnet mask is 255.255.255.0, and exit interface is tunnel 1. No IP root, which network? 30.1.1.0, 255.255.255.0, and tunnel exit interface is tunnel 2. Now you can see the routing table of R1. So IP root, there is no any entry for 20 network and 30 network. Fine. Let me remove a static routing from R3 as well. So go to configure terminal, no IP root, which network? 10.1.1.0, 255.255.255.0, and exit interface is tunnel 1, and we need to remove 30 network as well. Okay, now you can see the routing table of R3. So IP root, there is no 10 network and 30 network, right? Let me remove a static routing from R2 as well. Go to configure terminal, no IP root, which network? 10.1.1.0, 255.255.255.0, and exit interface is tunnel 1, right? And let me remove 20 network as well. So IP root. Now I am going to configure dynamic routing. Okay, so first of all I am going to configure dynamic routing on R1. See, go to configure terminal, router EIGRP, suppose AS number is 100, network 192.168.10.0, right? And wildcard mask is 0.0.0.255, right? And we need to run one more network command. This command will start sending hello message from tunnel 1, right? Okay, let me run 192.168.20.0 network as well. Wildcard mask is this one, right? This command will start sending hello message from tunnel 2, because we are running this network on tunnel 2. Now R3 and R2 is not receiving this hello message till now, right? So we need to configure EIGRP on R3 and R2 as well. So go to R2 first of all, and let me configure EIGRP. Router EIGRP, AS number is 100 and network is 192.168.20.0, wildcard mask is 0.0.255. You can see. So IP EIGRP neighbor. Who is my neighbor? 192.168.20.1, and exit interface is connected to which interface? Tunnel 1, right? This neighbor is connected on my tunnel 1 interface. Now let me configure EIGRP on R3. Configure terminal, router EIGRP, AS number 100 and network is 192.168.10.0, wildcard mask is 0.0.255. After running this command, R3 will also start sending hello message, and you can see the log message, neighborship is formed. So IP EIGRP neighbor, my neighbor is 10.1, which is connected on tunnel 1, but still I am not able to ping LAN user. Ping 20.1.1.1 and source is 10.1.1.1. Still I am not able to communicate, because in the routing table of R3 there will be no entry for 20 network and 30 network. So what we need to do, we need to advertise this LAN network in EIGRP. When I will advertise this network in EIGRP, this router will send update message, right? In that update message there will be information of this network. In the same way you have to advertise this network in EIGRP also and this network in EIGRP also, right? So go to R1 first. Let me start from R1. So go to configure terminal, router EIGRP, AS number 100 and network is 10.1.1.0. Now you can see the routing table of R3. So IP root. So IP root. You can see this entry, last one. This is D, means from EIGRP. 192.168.20.0 network. Okay, not talking about this network, I am talking about this network. This is my LAN network which is connected to hub router, right? And exit interface for this network is now tunnel 1, right? Exit interface is tunnel 1. But in the routing table of R1 there will be no information of 20 and 30 network. Let me advertise 20 and 30 network in EIGRP as well. So go to R2, configure terminal, router. First of all, let me show you the routing table of R2 as well. So IP route, there is 10 network, you can see, and exit interface is tunnel interface. Fine. Now let me configure EIGRP router. EIGRP S number 100 and network is 30.1.1.0. Now go to R3, sorry. So IP route. Now you can see there is 10 network also. Exit interface is tunnel 1 and there is 20 network also. 20 node, I am talking about 30 network here. You can see 30 network also, and exit interface is tunnel 1. Now let me advertise 20 network in EIGRP router. EIGRP 100 and network is 20.1.1.0. Ping 10.1.1.1 and source is 30.1.1.1. 20.1 na? Yes. See, now my LAN user are able to communicate. Go to, you can check on R3 as well. Ping 10.1.1.1 20.1.1.1 and source is 10.1.1.1. I'm able to ping 30.1.1.1 from 10.1. You can see I'm able to ping, right? So this is how you will configure point to point VPN. So here on R1 you can see there are 2 tunnels. So run interface tunnel 1. This is tunnel 1, and so run interface tunnel 2. So how many tunnel are there? 2. So if there are 100 branch, so you have to create 100 tunnel on this router. So this is problem. Okay, and this LAN user hub to SPOC to SPOC communication is not possible, right? Communication is happening through hub router, right? So in next video we will discuss DMVPN. So guys, that's all for today. If you like this video, please hit on like button. If you haven't subscribed my channel, please subscribe this channel, right? In next video we will discuss DMVPN. Okay, bye bye, thanks for watching. That's all for today.